Welcome to Alpha Bike Junior assembly video. I am Ali Sadat and I will be your guide through the assembly process step by step. Together, we will bring your bike to life. Without further ado, let's begin. To access build instructions, navigate to Sadat Akhavi Academy and scroll down to your Alpha Bike Junior kit. You can find complete assembly instructions here. There is a list of recommended tools to build this kit. After overview section, you can find the kit's inventory. Here is the 3D printing section. These are the parts that should be 3D printed using a 3D printer. Printing parameters like infill, quality, and filament types are suggested here as well. If you are using a service provider, there is a file called 3D Printing Asset Sheet, which can be found here. This file only includes the details service provider needs to print your parts. To download STL files, click on the link which takes you to Thingiverse. Then click on Download All. Navigate to the downloaded file, right-click, and click Extract. Open your printer slicer application. Yours might be different than mine, but the concept is the same. Configure your printer by selecting the correct nozzle, then ensure the quality and infill settings are correctly configured based on the instructions. Navigate to where STL files are, drag one of the files and drop it to the build plate, and ensure it is correctly seated on the plate. Repeat the same process for all parts. Pick the filament type and ensure the bed and nozzle temperatures are set as recommended by your filament manufacturer. Click on Slice and save the file to the disk. Repeat the same process for all parts. I personally do a final check on the G file to ensure the bed and nozzle temperatures are correct. Then print the part. In this section, we are going to upload the program to the microcontroller. In the first few pages, you will find the validation and installation process of the chip enabling ESP32 microcontroller to talk to your PC. Let's begin by connecting the microcontroller. Then navigate to Device Manager. I already have the driver installed, so my board appears under Ports. Your COM port might be different than mine, which is not an issue. If your board doesn't appear here, or it appears under Other Devices, click on the link in the document. Download the appropriate driver for your operating system and follow the process. In this section, we are installing VS Code and the Platform IO extension. Platform IO is a common IDE used to program microcontrollers. Navigate to the VS Code download page and download the proper version of VS Code for your operating system. Start with the installation process and follow the recommended steps. In VS Code, click on the extensions icon. Then search for Platform IO and click on Install. Here, we move to downloading the project's code and applying the proper changes. To download the code, visit the project's web page and click on Software Firmware link. Download the code as a zip file and extract it. Open Platform IO IDE. Navigate to the Projects folder to open the project in Platform IO. To configure Platform IO to communicate with the microcontroller, navigate to the Devices, Make sure the microcontroller is connected to your PC and click on refresh. Copy the port number and name. We use these values to configure platform IO config file, helping it to understand which device it has to upload the compiled code to. Paste the value for the upload and monitoring ports in the platform io.ini file. To configure the data communication channel between your bike and turbo thumb controller, go to setting and structs.hpp file and ensure the RF data channel value is the same as the one shown on the display of turbo thumb controller. This value should be between 0 and 125. Here, we are giving your device a unique ID, a value between 1 and E. You will be using the left side keyboard on your remote controller to select which device you are controlling and sending the control commands to. Now we are ready to upload the code to the microcontroller. Click on Upload button, which is a button with an arrow icon at the bottom bar of VS Code. To check if the microcontroller is programmed correctly, click on Serial Port Monitoring button, which is a button with a power plug icon. You should be able to see some incoming logs from the microcontroller. In this chapter, we will start assembling electronics, starting with resistors. In this kit, we have 4 22 ohm resistors to be soldered on the board. These resistors are for the amber lights used as indicators at the 4 corners of the bike. Resistors are color-coded, and you can decode the color coding using the links provided. The first link takes you to the guide on how the color coding works. For example, if you have 4 band resistors, the last band is the tolerance, and we are interested in the remaining 3. Band 1, red. Band 2, red. Band 3, black. Using the chart, the first band value is 2, the second band value is 2, and the third band value, which is the multiplier, is 0. It translates to 22 ohm resistor. The other link is another helpful resource. Just from the drop-down list, you can pick the color and it immediately shows the value on the screen. Use the picture in the guide to put the resistors correctly. On the left-hand side, we have to use 2 resistors to connect Y of LED to the third pin on the other side. You might have this as a G on your board. On the right-hand side, we connect Y of LED to the first pin of the other connector. You might have this as YR on your board. These are our 4 resistors. Starting from the left resistor, get one of the resistors leg through Y and the other leg through the third pin or G hole, and bend the legs on the other side. We follow the same process for the right side. On the right side, one of the resistor legs goes through Y and the other leg goes into first pin of the other connector. You might have this as YR. After we have all resistors in place, we can start the soldering process. After all legs are soldered, you can cut the extra legs using a wire clipper. Next, we move to soldering capacitors. This kit has 4 electrolytic capacitors. These capacitors have 2 legs with different polarities. One is anode or positive. This leg is usually longer than the other. The other leg is usually shorter and called cathode or negative. There is a mark on the body of the capacitor pointing to this leg. Here you can see the size of the legs. Short is negative, and it has a marker on the capacitor body pointing to the leg. Place them in C3, C4, C6, and C7 capacitor locations based on the suggestion value in the instruction document. Make sure the positive leg goes through the positive hole indicated by a plus sign. Then the legs at the back, after all are in place, you can start soldering and cut the extra legs at the end. This PCB has 2 jumpers on the board and a power switch that needs to be connected using pieces of wires. Let's cut 2 pieces of wire for jumpers, then connect the remaining to the switch. Don't keep the soldering iron on the switch for too long. It's made of plastic and can melt fast, like this. Now we start stripping 2 wires for jumpers. One is for MCU measuring battery voltage. Get the wire through holes, pull them tight, solder them in place, and cut the extra wire from the back. This one is for H-bridge power supply. Get the wire through holes, pull them tight, solder them, and cut the extra wire from the back. Now connect the power switch wires. You can do this from the top or the back. I suggest doing it from the back. The final look of the product will be better. Get the wires through the holes and solder them in place. This controller has a passive buzzer. The buzzer has two legs with positive and negative polarities. The positive leg could be identified from a plus sign on the top of the casing. The passive buzzer drive circuit is already on the board, and we only need to mount the passive buzzer in the location as shown. Place the buzzer in its appropriate place and make sure the positive leg goes through the positive hole indicated by plus sign, and solder them to the board. This kit uses a 9-volt battery as its power supply, and the battery connector should be soldered to its location as illustrated. Like the power button, you can do it from the top or from the back. I suggest to do this from the back. It helps with the look of the product. Next step is the motor driver H bridge module. We use the DRV8833 module in this kit, which is a very compact module capable of driving two DC motors in different directions. You have to solder the connectors to the module. The way that I found it much easier to do so is to put the connectors into their respective places and place the module on the top, then solder them. I solder legs alternatively to avoid overheating and cross-connecting connectors. LEDs have positive and negative legs. There are multiple ways of identifying them. The first one is the positive leg is longer and the negative leg is shorter. The other way is the casing of LED has a cut on the negative side. And the most reliable method is to look inside the LED. The positive leg or anode is shorter inside. These are the kit's two LEDs. One is for front light and one is for the rear. We are going to use two pieces of wires to connect them to the board. The 10mm LED, which is larger, is for the front light, and the smaller is for the rear light. Cut the LED legs, insert it to the wire, and connect the LED to the board. Make sure the positive leg is connected to the positive connector on the board. Repeat the same process for the rear LED, which is smaller. In this section, we are connecting the RF module to the board in the place as shown. Just place the module on the connector as illustrated. Then we connect the servo motor used for front wheel steering. The RF module should have its connectors already soldered, and it has been in place in the location shown here, and the module should easily fit in. The servo motor connector is located under the microcontroller. This connector has 3 pins, one for signal, one 5V, and the other one is ground. On the servo motor connector, brown is ground, red is 5V, and orange is signal, and we should connect them accordingly. Now we can place the microcontroller in its place and start testing. The microcontroller dev board has 19 pins, and the female connector on the board has 20 pins. One extra female pin. We need to ensure the microcontroller is placed correctly, and one extra pin that is not going to be used is close to the edge of the board. To test the board, connect a 9-volt battery to the board and turn on the power switch. LEDs should start flashing. Now we are ready to integrate the electronics to the main body of the bike. We start the assembly of 2 rear drive wheels. The tires are made of TPU or TPE and are flexible and should fit easily into the ring. Then use 2 screws for each wheel to secure the wheel connector shaft. Now we move to integrate the main chassis with the electronics. Start by passing the battery connector through these 2 holes. Then pass the power switch wire from underneath and place the switch into its appropriate place and secure the board on the chassis using these 3 screws. Here, we are going to assemble the back wheel assembly. Using the double shaft TT motor shoe mount, and 2 wheels we assembled prior. Then we have to connect the TT motor to these 2 pins on the controller board. We have to connect one of the wires to the TT motor. We take the wires and connect to the TT motor. We can solder the wires, but I found these connectors to be very sensitive and melt fast. I will just twist the wires very carefully instead of soldering them. In this step, we are going to integrate the motor module with the main chassis. Use 2 screws and add a spring as a shock absorber. Then you are fastening the main joint. If the part is not aligned correctly, the screw might break the part. Ensure the alignment is correct. Motor wires should be connected to output 3 and 4. We will check their appropriate placement soon. Place the microcontroller in its place. Ensure the unused female pin is close to the front of the board. To ensure the motor wires are connected correctly, connect a battery and turn the bike on. If it goes forward for a second, the connection is correct. If it goes backwards, which is the case here, we have to switch the placement of these wires with each other. After it's done, test the bike again. Now we can slide the extra servo motor cables under the microcontroller. Then mount the servo motor using 2 M2 screws. To connect the front steer wheel to To the main chassis, we use servo motor horns and screws provided. Connect the front assembly part to the servo motor. The default position of the servo motor when it is turned on is 90 degrees. Before screwing the servo motor horn in place, we need to validate this alignment. Slightly turn the front part to the left or right. Turn the bike on. If you are not satisfied with the alignment, you can refit the part again. Then we move ahead to connecting the wheel using a screw and 2 bearings. Now your Alpha Bike Junior assembly is complete, and you can take it for an exciting ride. Congratulations on completing the kit. I hope you learned something new today and had fun. If you would like to support my work, please like, share, and subscribe to my channel, and join our Discord server and leave a comment. Thank you for watching. Looking forward to seeing you in the next one.